Meet John Bardeen, the only person to win 2 Nobel Prizes in physics. He co-invented the transistor, launching the information age, and later decoded superconductivity. A humble genius, his quiet brilliance wired the world and built the foundation of every gadget you use today. Think it's Einstein? Guess again. While Albert is the face of physics, John Bardeen is the only person to win the Nobel Prize in physics twice. He revolutionized your world twice over, first with the transistor in 1956, and then for superconductivity in 1972. Meet the Einstein you've probably never heard of. While his name remains unknown to the public, his physics literally created the information age. From the modern electronics in your pocket to the MRI machines saving lives in hospitals, his theories made it all possible. He is a titan of solid-state physics, yet he remains a ghost in popular history. It's time to move past John Who and recognize the man who engineered our reality. Hollywood loves the mad scientist, isolated, erratic, and waiting for a magical flash of insight. But the reality of John Bardeen was far more grounded. Bardeen traded the chaotic chalkboard for a methodical, collaborative, and patient approach. He wasn't a hermit. He was a family man and a teammate who stayed rooted in the real world. He even found time for a hole-in-one at the Champagne Country Club. True genius isn't just about the eureka moment. It's about the work. John Bardeen's journey to 2 Nobel Prizes wasn't a straight line. It was a diverse intellectual foundation. Born in Madison in 1908, he mastered electrical engineering before making a bold move, abandoning a secure Depression-era geophysics job to pursue a PhD at Princeton. From elite fellowships at Harvard to vital wartime naval service, Bardeen combined theoretical brilliance with practical grit. He didn't just study physics, he lived through its most transformative era, preparing him to eventually rewrite the rules of our electronic world. In 1945, a powerhouse team at Bell Labs faced a massive technical hurdle, replacing hot, fragile vacuum tubes with a reliable solid-state amplifier. Director William Shockley proposed a field effect method to control semiconductor conductance, but theory wasn't matching reality. It kept failing in the lab. To solve it, he paired 2 opposites, Walter Brattain, the master experimentalist, and John Bardeen, the brilliant theorist. Together, they had to figure out why the physics were broken before they could build the future. To build the future, the team had to master the band picture of solids. In semiconductors, electrons need a specific jump in energy to cross a gap and conduct electricity. By adding impurities, they could manipulate this flow. N-type materials provide excess mobile electrons. P-type materials create holes, missing electrons that act as positive carriers. Understanding how these charges move was the secret to moving beyond the vacuum tube and into the silicon age. Why did Director Shockley's initial experiments fail? The answer lay in the invisible behavior of electrons at the edge of the material. John Bardeen realized that electrons weren't flowing freely. Instead, they were getting localized and trapped at the semiconductor surface. These surface states acted like a barrier, immobilizing the charge and blocking the external electric field from penetrating the material. This crucial insight didn't just explain the failure. It gave the team the roadmap they needed to finally bypass the problem and invent the transistor. By late 1947, theory finally met reality. Guided by Bardeen's surface state breakthrough, he and Walter Brattain successfully built the point-contact transistor. This tiny device replaced the bulky vacuum tube, launching the silicon revolution. In 1956, their monumental achievement was recognized on the global stage. John Bardeen, Walter Brattain, and William Shockley were jointly awarded the Nobel Prize in Physics for their investigations into semiconductors and the discovery of the transistor effect. After revolutionizing electronics, Bardeen wasn't finished. In 1951, he left the corporate world of Bell Labs for the University of Illinois. There, he established powerhouse research programs in both electrical engineering and physics. His mission? To solve one of the greatest mysteries in science, superconductivity. This phenomenon, where electricity flows with zero resistance, had baffled physicists for 4 decades. Bardeen was ready to trade the transistor for a riddle that would eventually lead to his second Nobel Prize. Imagine a material where electricity flows forever, without losing a single drop of energy. This is superconductivity. At temperatures near absolute zero, certain materials lose all electrical resistance and expel magnetic fields. For decades, this was the ultimate riddle of physics. The greatest minds of the century, including Einstein and Feynman, tried and failed to explain the mechanics behind it. As physicist Felix Bloch famously joked, every theory of superconductivity can be disproved. It was a mountain no one could climb until Bardeen arrived. Solving a 40-year riddle required more than one mind. It required a team with zero ego. Bardeen knew what he didn't know, so he purposefully recruited experts from entirely different fields to build a specialized unit. The team included Leon Cooper, an expert in nuclear physics and many-body theory, and J. Robert Schrieffer, a specialist in T-matrix methods. By sharing offices and planting theoretical seeds, they tackled the problem together, proving that the greatest breakthroughs often come from collective brilliance rather than isolated genius. In 1957, the team of Bardeen, Cooper, and Schrieffer finally cracked the code with the BCS theory. They discovered that electrons don't travel alone. Instead, they interact with the vibrations of the crystal lattice, known as phonons. This interaction acts like a microscopic glue, binding electrons into Cooper pairs. By moving through the lattice in a synchronized, effortless dance, these pairs bypass the obstacles that cause friction, allowing electricity to flow with zero resistance. John Bardeen's legacy was finally cemented in 1972. Alongside Leon Cooper and Robert Schrieffer, he was awarded his second Nobel Prize in Physics, this time for their microscopic theory of superconductivity. This achievement made Bardeen the only person in history to win 2 Nobel Prizes in the same field. Beyond the prestige, this work has a profound impact on our world, powering everything from life-saving MRI machines to the cutting-edge frontier of quantum computing. It is the ultimate testament to a life of quiet, world-changing brilliance. John Bardeen's 60-year career redefined the true measure of genius. He spent 6 decades driven by patience, deep intuition, and a profound belief in the power of teamwork. By rejecting the myth of the isolated, mad scientist, he proved that collaborative brilliance could solve the world's most complex riddles. From the smartphone in your hand to the laptop on your desk, the very device you are using to read this right now exists because of John Bardeen. To wrap up, let's look at the complete landscape of John Bardeen's impact. He didn't just participate in the scientific revolution, he architected it. The semiconductor revolution. By co-inventing the point-contact transistor in 1947, he provided the foundation for every digital device we use today. The theory of superconductivity. He solved a 50-year-old mystery with the BCS theory in 1957, explaining how electron-Cooper pairs allow for zero electrical resistance. Academic leadership. For 4 decades, he shaped the next generation of minds as a professor of physics and electrical engineering at the University of Illinois. With 2 Nobel Prizes in physics and the National Medal of Science, Bardeen remains the father of the information age. His legacy proves that fundamental theory, when paired with collaborative spirit, can quite literally change the course of human history.